The half-life of a radioisotope is the time taken for the sample's activity to fall by half. This can be easily calculated using the following formula triangle. At the top we have the total time, and underneath we have the half-life of the sample and the number of half-life periods, i.e. the number of half-lives that the sample has undergone. To simplify this and make it much easier to remember, we can write it in this shorthand where total time becomes TT, half-life becomes T a half, and the number of half-lives just becomes number of T a half. Now there are multiple different ways that this triangle and these formulas can be used to calculate half-life, and we're going to look at 3 different ways today. Type 1. Calculating the mass left after decay has occurred. Americium-242 has a half-life of 12 hours. A researcher started with 10 grams of americium-242. Calculate the mass remaining after 48 hours. Okay, so our first step is to calculate the number of half-lives. Let's just write out the formula triangle to keep us right here. Okay, so we know that its half-life is 12 hours. Okay, and we know that the total time we're interested in is 48 hours, so we can calculate this out. So the number of half-lives that's undergone is 48 divided by 12, which is 4. So we've had 4 half-lives. Step 2 is to calculate the mass left. Okay, so if we start off with 10 grams, and in our first half-life period we half that down to 5 grams, and then we have our second half-life period where we half that down to 2.5 grams. Our third half-life period we go to 1.25 grams, and then we have our fourth and final half-life period that takes us down to 0.625 grams. Therefore, the mass that remains of the sample after 48 hours is 0.625 or 0.63 grams. Let's have a look at another one of these types of questions. A radioisotope has a half-life of 4 hours. Calculate the fraction that will remain after 12 days. Again, step 1 is to calculate the number of half-life periods. Okay, so from our triangle, number of T a half is your total time divided by the half-life. From the question we can see our total time is 12 and our half-life is 4. Now there's a typo in this question because obviously that should be the same, and if you were given an SQA question they would obviously be the same. They wouldn't expect you to do a conversion in your exam. So we can see here that we have 3 half-lives. It's asked us to calculate the fraction, so we start off with a whole 1 And then we have 1 half-life period that takes us to a half, 2 half-life periods that takes us to a quarter, and our third and final half-life period that takes us to an eighth. So for this question, an eighth of the sample will remain. Now another way that we can use this formula to calculate is actually to calculate half-life itself. So we've got the number of half-life periods and we know the total time, and we can use that to calculate the half-life of that radioisotope. So here we have question 1. The mass of a radioisotope falls from 3.8 grams to 0.47 grams in 9 hours. Calculate the half-life of this radioisotope. So the first thing that I'm going to do here is I'm going to draw out my triangle. Now straight away we can see that we have the total time, that's the 9 hours, so we've got that. It's asking us to calculate the half-life, and the number of half-life periods we can work out from our falling mass. So 3.8 grams halved is 1.9, 0.9 halved is 0.95, and 0.95 halved is 0.475 grams. So we have 1, 2, 3 half-life periods. We can then substitute that information up in our triangle. So step 2 is to calculate the half-life. T a half equals the total time divided by number of T a half, number of half-lives. So our total time is our 9 hours divided by our 3 half-life periods. So our half-life is 3 hours for this sample. And the third and final way that we can use this formula is to calculate the total time that it takes for a radioisotope to disintegrate. Here we have carbon-14 has a half-life of 5,600 years. An analysis of charcoal from a wood fire shows that its carbon-14 content is 25% native living wood. How many years have passed since the wood for the fire was cut? Again, let's start off by drawing a triangle. We're looking to find the total time. We know the half-life because it's given to us in the question, and we need to work out the number of half-life periods. So step 1 again is work out number of half-lives that have occurred. We're talking about percentages in this question, so when we start out we're starting with 100%, we half it and go to 50%, and then we'll half that again and go to 25%, and if we go back and count our half-lives 1 and 2, we can see that we have 2 half-lives that have been passed during this time. Step 2 then, we can go on and we can use the formula to calculate the total time. So total time equals the half-life times the number of half-lives passed. Our half-life is from the question, 5,600 years. Times that by the number of half-lives that have passed, there's 2. And when you multiply that, we have 11,200 years. and that is how many years have passed since the wood for the fire was cut.